was towards the end of the war that I finished schooling, high school, and I had to get a job, and I got a job in a paint company. Paints are essentially a mixture of two components. One's the pigment or the colour, and the other's the thing that binds them together, and that's a polymer. And I became very interested in the polymers, particularly the chemistry of the polymer systems. I started off in the factory doing factory testing. I moved to the development lab, and then they set up a research lab. At Dulux, I was being encouraged into management. I didn't want to do that, and so I left and went to CSIRO. I'm most known for the plastic banknotes, or polymer banknotes, but at the same time I was starting to work on what now we call living free radical polymerisation.
At high school, chemistry was one of the subjects that I enjoyed most. Within chemistry, I developed interests in biologically active compounds, pharmaceuticals, because I could see them as being of benefit to humankind. And so I spent really many years in that field. And then Dave Solomon advertised a position in polymer chemistry, and I said, well, I'll give it a go. And then we never really looked back. We knew that polymers were not being made as well as they could be. Dave and I realised that an important thing was to try and understand the process of polymerisation itself. How do these molecules form? How do they come together?
When you make a polymer, you start off with what's called a monomer, and you zip them all up together in a long chain. To start that chain growing, you add a compound called an initiator. I thought that the initiator was influencing the properties, and so we wanted to study the initiator fragment. That's very, very difficult because it's 1 unit in 100,000, and the techniques weren't there to do that. At CSIRO, with Ezio, we found a method of isolating that first reaction that occurred so we could identify how the initiator attacked and started the chain. It was a major breakthrough. You could write molecular structure down and then go and make it.
These methods that we invented and developed allow you to make polymers that were not possible before. It allows you to develop products that were not possible. You can now attach well-defined polymer chains to pharmaceuticals for drug delivery, to make the drug more soluble, to make it longer lasting, and to make it less toxic. Our technology is used widely today. Some 60 companies have taken out around 500 patents.
It's very satisfying to see people using our methods of controlling polymer structure. I'm 82 this year, but I'm still excited about science, about chemistry, and I still go to work. I do it because I'm fascinated by it.